In this video, we're looking at how to find the gradient of a straight line. So our key information we need to know to start with is that the general form of a linear equation is y equals mx plus c. And I've intentionally made m and c different colours because we need to know what they mean. We should know that y and x, we've got coordinate grids where we have axes, and you have an x-axis and a y-axis. So x and y are just going to be coordinates from those coordinate grids. But our m part is something called the gradient, which of course we're looking at today. And our c part is called our y-intercept. That just means where the line crosses the y-axis. So when we're looking at gradient we can also describe as the steepness of a line. Okay, so if it gets taller faster than it goes across, we know it's got a bigger gradient. So it's a steeper line, it's got a bigger gradient. So we can also say that. So just a few notes to get started in order to help us compare as well. So if we have a look, so this line isn't on the coordinate grid, but we should be able to work out a gradient here. So here's a line, we're going to find the gradient. So example 1, find the gradient. Okay, so we've got this line here, and all we want to do is find out how much it goes up every time it goes across by 1 square. So that's 1 square to the right. Yeah, so we could say that in brackets. So how many squares up every time it goes 1 across, specifically to the right. So we use a method called the right-angled triangle method. So we're going to use this end of the line to this end of the line. Now some of you might have already spotted what you think the answer might be. You might have just gone across 1 square and seen how far up. But if we look here, we've gone 2 to the right, and we've gone 4 squares up. Okay, now, as I said, some of you might have spotted, if we go 1 right, we go 2 squares up, so you're thinking the gradient is 2. If you do think that, you are correct, so well done. Okay, but I'm just going to show you how we would work it out mathematically as well, maybe if it didn't go exactly 1 square across. So we use something called either rise over run, or we call it the change in y over the change in x. And if you think about it, rise means we're going higher. Okay, so that's our change in the y-axis, how many up we go. Run, when we run, usually we're going just across. So in this case, how many right we're going, so it's how much we go on the x-axis. So on our y-axis, or our rise is 4. Our run, our x-axis would be 2. So 4 divided by 2 gives us 2. Okay, so those of you who said gradient of 2, as we've seen here, it is correct. So if you worked it out this way, or if you just went 1 across and went up by 2. Looking at example 2, we're looking at 3 lines all on the same grid, and there's 3 parts to this example. So first of all, we need to find the gradient, which we've practiced already. Okay, and then part B, for each line, we're going to find the y-intercept, which is something we spoke about, and we're going to look at what that is. And then finally, part C, what is the equation of each line. So once we know the gradient and y-intercept, we can also name the equation. So just taking this gradient a little step further. A couple of reminders here for us. Gradient is rise over run, so how far up or maybe down we go, and how far right or left we go. Okay, and the reminder here that the general form for our linear equation can always be written as y equals mx plus c, where m is the gradient and c is the y-intercept. So you'll see here I've already labelled 1 point, and I've just marked on a 2nd point on our grid, we've got 2, 7 here. And this one here is 3, 10. Those are our 2 coordinates. I've chosen those coordinates specifically because they have exact values for x and y. So for example, if we pick this one here, where we can see y is 9, okay, it's part way between 2 values of x. So if we look down, it's between 2 and 3. Okay, so we can't tell specifically whether it's exactly 2, exactly 3. It's clearly not exactly because it's between, or also whether it's exactly halfway. So we're not going to use that point, we're going to use 2 exact coordinates. Now, like we did before, we're going to use our right angled triangle method. So here's our right angled triangle, and we're going to use our rise over run. So our rise, if we went from 7 up to 10, or in this case we can count the squares, our rise was 3 here, wasn't it? And if we look at our run, how far across we went across by 1. So for the line drawn with black, our gradient is 3 over 1, which means 3 divided by 1. So the gradient is 3. Okay, if we move on to the blue line now, again, we're going to find 2 exact coordinates. So I'm going to go with this one here, and just any at random, we'll go with this one here. So this one here is 4, 4. This one here, just double check, is 8. 8. So again, let's use our right angled triangle method. So we need to look how much did we go up, how much to the right did we go. So we went from 4 up to 8, and from 4 across to 8. So both are a change of 4. So for our blue line, our gradient is 4 divided by 4, which equals 1. Finally, for our red line, again, 2 exact coordinates. So we'll go with this one here, and we'll go with this one right at the end. So if we look here, how many squares up did we go? 1, 2, 3, 4. How many squares to the right? 1, 2, 3, 4, 5, 6, 7, 8. So our gradient for our red line is 4 over 8. And actually, that's not a whole number, but if we simplify the fraction, it gives us a half. Okay, so that's part A done. There's our 3 gradients. Part B, we need to find our y-intercept. And as we said before, the y-intercept is just where it crosses the y-axis. So if we look at the graph here and we look at just our black line, if we follow it down all the way to the y-axis, it crosses the y-axis at the number 1. So for our black line, the y-intercept is 1. For our blue line, if we follow it all the way to the y-axis, it crosses at 0. And for our red line, it meets at the same point as the blue. If we have a look here, so our y-intercept is also 0. Okay, so part C was done, nice and easy. Finally, for part C, we need to write the equation of each line. So for our black line, we've got a gradient of 3, we've got a y-intercept of 1. So we're just going to copy this rule here, leave y as y, leave x as x, and we're just going to substitute our gradient into place of m, and our y-intercept into the place of c. So we've got y equals, instead of m, for our black line was 3. We're going to keep x there. And then our y-intercept was 1, so plus our y-intercept. So line C is the line 3x plus 1. Okay, the second one for part C is our blue line here, a gradient of 1, a y-intercept of 0. So y equals, and our gradient was 1. So instead of m, we're going to put 1, keep our x, and then plus our y-intercept to 0. Now actually that is correct, but we can make that a lot neater, probably more mathematically accurate as well. We don't need to put this 0 here. If there's a value of 0, it doesn't exist, so we don't need anything. And also if we just have 1x, we might know that we can just write it as x instead of 1x. So instead of y equals 1x plus 0, we're just going to write y equals x. There's nothing added to it at the end, so it's just y equals x. Okay, our final one on part C, our red line here, gradient is a half, y-intercept is 0. So So again, we're going to keep the y. Instead of m, we're going to put a half. And it would be plus 0, but like we said here, we don't need the plus 0, so we're just going to leave it as y equals a half x. Okay, now we should know how to find the gradient. Okay, and we've got a little bonus of the y-intercept and the equation of each line.